Okay, let's dive right into this explainer and demystify the epic 165 million year saga of the dinosaurs. For millions of years, these incredible creatures just completely dominated the Earth, shaping entire ecosystems and defining an era unlike literally anything else in history. Today, we're going to trace their complete journey, from their honestly kind of humble evolutionary beginnings as these small survivors, straight through their absolute reign as towering giants, and finally to their sudden, fiery ruin.
165 million. I mean, wow. That staggering number represents the amount of years these creatures ruled the Earth. Just think about that for a second. To put that into perspective, our entire human history is barely a fraction of a drop in the bucket compared to that. We're talking about a reign far, far longer than our own, spanning this unimaginably vast stretch of deep geological time. So, here's how we're going to break this down. We'll start with the dawn of the dinosaurs, move into the Triassic Period where they were small and fast, step into the Jurassic Age of giants, hit the Cretaceous peak of diversity, and then we'll wrap up with the asteroid impact extinction. Now, getting a grip on this timeline actually corrects some pretty wild myths. Like, here's a classic. Did a T-Rex ever battle a Stegosaurus? Well, the answer is an absolute no. It turns out the late Cretaceous T-Rex actually lived closer in time to us, literally, you and me sitting here today, than it did to the Jurassic Stegosaurus. Crazy, right? It just shows you how incomprehensibly long 165 million years really is, and why breaking this down era by era is absolutely crucial. All right, part 1, Dawn of the Dinosaurs emerging from the ashes. Let's go all the way back to the very beginning of the Mesozoic era. So the dinosaur lineage actually began as total underdogs. They were essentially emerging from the ashes of a catastrophic event known as the Permian mass extinction, which hit about 252 million years ago and wiped out, get this, up to 90% of life on Earth. 90%. But in the aftermath of that global devastation, reptiles began to evolve and diversify. We see the first archaeosaurs pop up around 245 million years ago, and they eventually paved the way for the very first true dinosaurs about 230 million years ago. Moving right along to part 2, Triassic, small and fast. During this period, the Earth was essentially this hot, dry supercontinent called Pangaea, and dinosaurs, well, they were definitely not the dominant predators yet. Early dinosaurs slowly started to spread across the different regions of Pangaea. During the late Triassic and early Jurassic, they were establishing footprints across massive land masses, places we now know as South America and Africa. But here's the thing. Even though they were spreading globally, they were still just a marginal group. They were really just trying to navigate a harsh, incredibly competitive world. To give you an idea of what they looked like, early species like the Eoraptor and Herrerasaurus were these small, fast, bipedal survivors. I mean, some were literally about the size of a dog. You also had species like the Plateosaurus, which was this early herbivore adapting to plant life, kind of dropping a hint at the massive plant eaters that were yet to come. But honestly, at this point in the Triassic, they were heavily overshadowed in most ecosystems by these giant crocodile-like archosaurs, who were the real kings of the landscape. That brings us to part 3, Jurassic Age of Giants. This is where a massive shift in climate ushered in the golden age of massive dinosaurs. So, following another mass extinction event about 201 million years ago, one that conveniently wiped out a ton of those archosaur rivals, the dinosaurs finally, truly took over. Between 201 and 145 million years ago, they just exploded in size and diversity. Without all that heavy competition, giants like the Brachiosaurus absolutely thrived around 160 million years ago. Think about the sheer evolutionary leap in scale here. You've got the Triassic Eoraptor, nimble, walking on 2 legs, and basically the size of your pet dog. Contrast that with the Jurassic Brachiosaurus, a towering 4-legged herbivore growing over 20 meters long. It's just a phenomenal physical transformation, and it was a direct result of evolutionary opportunity and a rapidly changing climate. And the environment was perfect for them. The warm, humid Jurassic landscape provided this incredibly lush vegetation that fed massive herds of sauropods, like the Diplodocus. At the exact same time, you had heavily armed herbivores, like the Stegosaurus with its distinct backplates, evolving to defend themselves against fearsome, newly evolved apex predators like the Allosaurus. Oh, and this is super important. We also see the appearance of the Archaeopteryx right around now. This guy was bridging the gap between reptiles and modern avians as one of the very first bird-like dinosaurs. All right, moving into part 4, Cretaceous, peak dinosaur diversity.
This era marks the dramatic, highly diverse climax of dinosaur evolution.
Spanning from 145 down to 66 million years ago, the Cretaceous was actually the longest era. Around 145 million years ago, the supercontinent began to break apart, creating these isolated environments. By 90 million years ago, the global climate was so warm that rainforests were literally thriving near the South Pole. I mean, no way, right? And then, around 68 million years ago, the most famous predator of all time, the Tyrannosaurus rex, finally steps onto the scene. All this continental separation caused an absolute explosion in unique, highly specialized species.
This is the era that brought us the real iconic heavyweights. We're talking about the apex carnivore, the theropod T-Rex, with its literal bone-crushing jaws, evolving right alongside the herbivorous ornithischian Triceratops, rocking that massive frill in those three horns. They ruled together during a really pivotal time, right when the very first blooming flowering plants were beginning to completely transform the global food chain. And the academic literature really highlights how complex and highly specialized these carnivorous theropod families became right before their sudden downfall. The evolutionary divergence of groups like the Tyrannosauroids shows us a true peak in biological specialization. They were absolutely at the top of their game, having adapted perfectly to their specific ecological niches all over the globe.
But all good things must come to an end. Part 5, the asteroid impact extinction. We have reached the apocalyptic conclusion of their reign, a catastrophe that happened in a literal flash and reset the entire planet.
Exactly 66 million years ago, everything changed. A devastating asteroid, roughly the size of Wellington Harbor, if you can picture that, crashed into the shallow seas off the Yucatan Peninsula in modern-day Mexico. The impact was just unfathomable. It released the equivalent energy of several million nuclear weapons detonating simultaneously.
The stark numerical reality of the aftermath? It's pretty devastating. 75% of all life on Earth was completely wiped out. All non-avian dinosaurs, marine reptiles, and large tetrapods just vanished into the fossil record. Only about 25% of life, which included early mammals, small reptiles, and, crucially, avian dinosaurs, managed to survive the resulting environmental collapse. And just like that, the glorious age of dinosaurs came to an abrupt, tragic end.
So we have to ask, did the timeline really end there, or do we still live among dinosaurs today? Well, the crucial takeaway here is that while the giants fell, small avian dinosaurs actually survived that fiery impact. They endured, they adapted, and they left a feathered legacy that is probably flying outside your window right now. The age of dinosaurs as we know it may have ended, but their descendants are still very much with us. Looking back at this incredible 165 million year journey, what other secrets of survival do you think are still waiting to be unearthed in the fossil record?